In this lesson, we're going to be learning about the Pythagorean Theorem. So if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. And the hypotenuse is always the longest side of the triangle. So that would be displayed as a squared plus b squared is equal to c squared. And if you see the little display at the bottom left, it kind of shows how the Pythagorean Theorem works. So finding the length of the hypotenuse. What is the length of the hypotenuse of triangle ABC? Again, we've learned a squared plus b squared is equal to c squared. Now let's substitute the values. So we have 20 squared plus 21 squared is equal to c squared. Now let's simplify. 20 squared is 400. And 21 squared is 441 equals to c squared. 400 plus 441 is 841 equals to c squared. And then we take the positive square root of that. So c would be equal to 29. And we would write the hypotenuse right here, 29. Now the next question asks, do the side lengths of triangle ABC form a Pythagorean triple? Well, what is that? Here's the definition. It is a set of non-zero whole numbers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. Well, in this situation, we have 20 squared plus 21 squared is equal to 29 squared. So this forms a Pythagorean triple because there are whole numbers that satisfy a squared plus b squared is equal to c squared. Finding the lengths of a leg. Now in this situation we have the hypotenuse and we're looking for the side length of another leg. So again, using a squared plus b squared is equal to c squared. Here, let's substitute the values. So one of our legs is 8 squared. We don't know what the other one is, so let's leave it b squared is equal to the hypotenuse 20 squared. So let's simplify. 8 squared we know is 64 plus b squared and 20 squared is 400. Now we're solving for b, so let's subtract 64 from both sides of the equation. And we're left with b squared is equal to 336. We'll take the positive square root of both, and b is equal to. Now, let's factor 336. We can get that by doing 16 times 21. Now, to keep this in a radical form, let's keep factoring this. So 16, we can get 2 times 2 times 2 times 2, that gives us 60, and to get 21, it is 3 times 7. Now remember, for every 2, we take 1 out, right? So b is equal. We have 2 other 2's here. Take another 1 out, and we're left with the 3 times the 7 inside. So b here is equal to, outside we're left with 4, 2 times 2, radical 21. So the length of the other side of this triangle, x, would be 4 radical 21.